All right, hello, welcome back. It's a new day. Talking about introduction to research summaries, a new type of passage. So plan today. Going to look at data rep homework number 6 just real quick. Hopefully you're looking at those keys. Talk about introduction to research summaries. There won't be homework today. You'll just have to do the third passage that I don't lead you through. You'll have to do that by yourself and check it against the key. That's it. Easy peasy. Should be a short day. So let's get into looking at the homework from last time. All right, so going back and looking at group work number 6 from last time, there's a few questions I wanted to make specific mention of. Number 5, based on figures 1 and 2, if we had MnSiO3, where would we expect the peaks to show up? I don't know, like maybe where the Mn was, where the Si was, where the O was, I don't know, 0.7, 2, 6. Yeah, we get something like that. A. You can do that. That's cool. Second one, you just had to match these symbols up. There wasn't a quick way to do a lot of these. You just had to say, okay, find the goofy symbol. Where does the goofy symbol show up? So hopefully you've said, oh, that's a goofy symbol, and said, ooh, there's a goofy symbol, and oh, that's yolk sac liver. Do I know anything? No, but I can match up the goofy symbol. Last one, you needed to do a little bit of reading to figure out, okay, I got to go from 2 to 10.4. What is that? That's multiplying by 5. Pyrex glass times 5.2. You just need to say, okay, how do I get from 2 to 10? Multiply. Right. Nothing big on there. You should talk with me about specific questions you have on that, because today we're going to get into a new topic. That new topic being research summaries. So let's mark up the front page of this thing. Red pen. There we go. Research summary passages strike a middle ground between graphs and text. There is some of both. There are always going to be 3 of these. They're the most common. So we got some of both. We got some graphs. We got text. So we have to combine graphs and text. Cool. How do we tell? They're going to have italicized headers. They're going to describe a series of experiments or studies. So it'll often be like experiment 1, 2, 3, or study 1, 2, 3, etc. Okay. Next, whatever. Students must be able to understand the rationale behind experiments and think scientifically. That is the why sort of questions. Why do we do this? Why did we perform this experiment? You're going to have to use the text in conjunction with the graphs and tables. You're going to have to put them together. It says you're going to try and understand. You're not going to understand things. You're going to start reading the questions. You're going to have some questions that will occur pretty frequently. What happened? That is questions dealing with the procedure. What were they trying to prove or understand? That's often going to appear in the introduction. What changed? That's going to show in the procedure. And you're going to be tipped off by the word except. Everything was the same except. And how did those major changes help with understanding? Why did we do that? That's the hard question, right? So you're going to have to understand a little bit about at least how the data was gathered and maybe a little bit about why they did it the way they did. And that's going to be a little more challenging than just picking out information from a table. So let's jump in and look what that it looks like. I'm going to do the first one with you. You're going to do the second one timed, and then you're going to come back and follow along with me. And then you're going to do the third one's homework. There is no separate homework packet. This is everything you're doing for today. That date's wrong. It's from a couple years ago. Don't worry about the date. So jumping into things, we got a passage 1 here at the beginning. It's going to be our very first research summary we look at together. Notice what we have here. This is a little different. We have kind of a procedure, and we also have results. This is new. We used to just have what are the results of the experiment, but now we have what's the procedure as well. So what did we do? What is the data? What did we do? What is the data? Cool. So let's jump into it. Sorry for yawning. Talking about number 1. In which of studies 1 and 2, okay, did some of the fruit flies live for more than 75 days, and what diet did they get? All right, so we got to find, back in studies 1 and 2, we're looking for fruit flies that lived more than 75 days. I look at these two graphs, and I only see one of them, percent alive, or 75 where it's not 0. So that's right there. This is from study 2. And what were they fed? These guys were fed 5% sugar yeast medium. So we can use the key, we can use a little bit of reading to come up pretty quickly with that answer of C. All right, 1 down. Number 2. During studies 1 and 2, why, all right, oh, we got a why question. During studies 1 and 2, why did the size of the fruit fly population in each tube decrease rather than increase? So why did the population decrease? And we got something about males, virgin females, and we got a couple pairs involving birth rates and death rates. So we can cross out one of those right away. If the death rate was 0, what does that mean? Nobody died. If nobody died, the population wouldn't go down, it would only go up. So we can easily cross out H and J because it doesn't make sense for the death rate to be 0. It must be the birth rate is 0. That's why the population is not going up. What would cause the birth rate to be 0? Well, either of those are plausible explanations, only males or virgin females, but we need to word search to find the difference. Word search. And one of those words is going to jump out at you. Males or virgin females, one of those is going to jump out at you. If you do this, you very quickly will find that 200 virgin female fruit flies were placed in the tube. Why is this important? They haven't been impregnated by the male fruit fly. They can't have babies. Nothing should be coming out here in terms of new population. So the answer there, G, virgin females. Cool. So we can look at like a little bit of graphs still. We can word search things that seem to be important. Great. It's a little harder, but you know, we can do this. Number 3 here, study 1 differed from study 2 in which of the following ways? When you see this word differed, you need to look for words like except. What was different in the procedure? The word except is often going to key you off. So what was different between fruit 1 and 2? Well, you'll notice that these are talking about the gender of the participants, and these are talking about the sugar yeast medium. This is female, male, male, female. But we should cross that out because we know that it was all female, virgin females in both. So we know it's not going to be A or B. Now the question is C or D. What's the difference between C and D? Study 1 is lower than study 2. Study 1 is higher than study 2. You just got to figure out, is study 1 lower or higher than study 2? If you go back and do that, study 1 is 15, study 2 is 5. Study 1 is higher than study 2. Study 1 is 15. Study 2 is 5, so study 1 is higher than study 2, so that will be answer option D. Cool. Number 4. Suppose that an additional trial in study 3 had been performed at 12%. The average life of strain X would most likely have been. Okay, well, I go over here and I look at study 3 right here. And I look at table 1, which is where it falls, and I see here strain X. Okay, that's very nice. And I see, oh, 12. Well, we don't have a measurement for 12, but we have measurements for 10 and 10 and 15. Sorry, I'm just letting some people into a Zoom meeting. So if the sugar percent's between the 10 and 15, I might expect the lifespan to be between those 10 and 15 values, 55.6, 58.6. You can circle answer option G on that one. What else do we have? 2 questions left, questions 5 and 6, and then we'll pause it for a moment. Number 5, the fruit flies had predicted. Okay, we made a prediction. We predicted that decreasing a fruit fly's ability to detect odors would increase its lifespan. Are the results of study 3 consistent? Okay. Ability to detect odors. Okay. What the hell is that about? All right. Strain X fruit flies cannot detect odors. Oh, so X, no smell, and N can smell. So you needed a word search. What's this ability to detect odors? Okay, we took away their ability to smell, and we said, well, how long are they going to live if we take away their ability to smell? Did they live longer? All right, the no smell, they live longer than the smell. All right, so does taking its ability to detect odors increase its lifespan? Yeah. Yes. Strain X fruit flies longer than strain N. So you notice there was the no and the yes option. We cross out the no option. And then either X is longer than N or N is longer than X. The only way that makes sense is if X is longer than N. 2 left, and it's going to get harder here at the end because we got 2 questions here, going to get a little more challenging. So let's take a look at number 6, and then we'll 6 and 7, then we'll pause it. So number 6. What color? Orange here. Suppose, not pink, I know my colors. Researchers want to determine whether a defect in the ability to detect odors, okay, you know that, that's X, would change when the lifespan of fruit flies fed 15% sugar yeast medium, when live yeast is added to the diet, or when additional odors. Okay, which of the following experiments should be performed? Okay, so defect in the ability to detect odors, that's X, so right away I can cross out G and J. 15%, which one had 15% in it? You take a look back at the previous table, you see, okay, previous page, who had 15%? Study 1. Study 1, strain X, answer there, F. And then one more to go. The results for which 2 tubes should be compared determine how a reduced calorie diet affects lifespan in the absence of live yeast and additional odors from the live yeast. Absence, again, means it's not there. So we don't want live yeast or additional odors from live yeast. So we don't want additional odors. We don't want live yeast. We don't want additional odors. We don't want live yeast. That would be 1 and 4. 1 and 4 would be the ones we want there. So we're going to go ahead and click answer A there. I'm going to pause it. Get some people started on their practice test. I'm going to come back. We're going to do the second passage. If you wanted to pause right now, work that second passage, that'd be a good idea. And then that third passage is going to be your little bit of homework. All right, well, got some kids taking a practice ACT. This is what it looks like. This is what proctoring looks like. So I got some folks taking a practice ACT over there, so that's fun times. Let's move on to the next passage, talking about somebody joined on me. Take a look at the next passage dealing with what do we got on the next passage? Fun times, acid-base indicators. You might have talked about these in chemistry at some point. These are things, chemicals that color changes based on the pH of the solution in which they are in. So let's jump into it. You should have paused, tried this one on your own. Let's work through it together. Number 27, one way in that experiment 2 differed from experiment 3 was that in experiment 2, again, that word differed, often going to see except show up. Experiment 2, experiment 3, oh shoot, what do we got here? So it's either known or unknown pH, or it has something to do with Mentonil yellow, was used or not used. Well, Looks like Mentonil yellow was used in both of these, so it's not that. So I can cross out C and D because that appeared in both of them. So in experiment 2, were they known or unknown pHs? In experiment 2, these were known pHs. If we had known pHs, that's going to be answer option A. That one's a little confusing because of how it's worded. Number 28, based on the description of the well plate. Description of the well plate. You can read that. And how it was used, the empty well plate would have been, most likely have been which of the following colors. And if you're, well plate, let's go look for well plate. A plate containing a matrix of round depressions. Okay, so they used colorless aqueous solutions and a well plate. If they're trying to look at color, do I want to put things in a colored cup or a clear cup? I want to put things in a clear cup or a white cup, a cup that's not going to influence my ability to discern what color it is. Perhaps you've seen these things before. These well plates are often clear or white. Okay, so number 29. Based on the results of experiments 1 and 2, which of the following is a possible transition range for curcumin? And if you didn't know what transition range was, you might need to word search for that. If you go back and look for transition range, you find it right here. The transition range, the indicator's color will be an intermediate if it's other two colors. Intermediate, in the middle. That word intermediate, in the middle, mediate, the median. Those are all related principles. The middle, mid. Cool, so what's in the middle? When is it changing colors? Basically is what that transition, to change from one to another. So transition range for curcumin, and I look at curcumin, I say yellow, 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 and I see over here curcumin, oh, it's orange in the middle. So that's where it has transitioned from yellow to red, with orange being a pretty reasonable intermediate in the middle between yellow and red. So that's 8. So I'm looking for the range that includes 8. Only one range includes 8, so that's going to be answer option C for us there. So now let's jump to black here. A chemist has 2 solutions, one of pH 1 and one of pH 6. Based on the results of experiments 1 and 2, could indigo carmine be used to distinguish between these solutions? Distinguish. What does distinguish mean? Tell them apart. Tell apart. That's the official science definition of distinguish there. Indigo carmine, 1 and 6. Well, let's look at indigo carmine. It's right here. At 1, it's blue. At 6, it's blue. Can I tell the difference between 2 blue solutions? No, they're both blue. No. Indigo carmine is blue at both pH 1 and pH 6. That's F. Can I distinguish between 2 identical twins that I don't know? Don't know which way they style their hair or something? No, I can't tell them apart. They're hard to distinguish. Keep it rolling. Let's go with pink here for number 31. The indicator propyl red has a transition range of 4.6 to 6.8. If propyl red had been included in the experiments, it would have produced results most similar to which of the 5? 4.6 to 6.8. So we're talking in, here. Who changes in there? Resource and blue is changing in there. It's purple. It goes from red to purple to blue in that range. Answer is going to be B, resource and blue on that one. Let's go green. 32. The student claimed that solution 3 has a pH of 7.3. Are the results consistent with this claim? Solution 3, 7.3. All right, well, here's solution 3. And the question is, does this look like something that has 7? So Mentonil yellow is yellow. Okay, that matches, yes. Resource and blue, at 7, resource and blue should be blue. But over here, resource and blue is red. There's a disconnect. Resource and blue appears red. If it's red, where's red, resource, and blue? That's down here 0 through 4. So is it plausible? No. because solution 3, resource in blue, was red. Answer option G there. Okay, and then one left, and the one left is the hard one. It's the hard question. Talking about stuff you don't know based on the results of experiments 1 through 3. Okay, so you got to combine all sorts of information. That already makes it gross. Which of the solutions has the lowest pH? If you're ever trying to find the extreme, we're going to look for the unusual responses. If you want to find an extreme, look for the one that did something weird that everything else didn't do. So looking for lowest pH. Where's something that stands out? I look back at table 3 and I see, okay, solution 4 was orange here. That's an unusual one. Solution 2 was yellow here. That's an unusual one. So we're looking for low pH. Where does orange mentoneel yellow show up? It shows up at pH 2. Where does yellow indigo carmine show up? 13 and 14. Look for the unusual thing. Find the unusual thing. One of the weirdos is going to be a low or a high value. We found that the orange mentoneel yellow has pH 2. That's the only one that was orange. So that's going to be our answer of D, solution 4. You've got one more passage to do by yourself. The third passage in this packet dealing with spraying mud on the ground and seeing, well, how much light does the mud on the ground reflect? How much temperature, or what's the temperature of the ground now the mud's been sprayed on it? You've got a key. You're going to check it. This is a single assignment today. Participation, homework, all bundled into one. We'll see you.